12.3, solving radical equations. All right. So up to now, we've been looking at radical graphs and other graphs, right? We have the graph of x squared, which is our parent function for all parabolas in the whole wide world. They bounce at the origin. That's where the vertex is. Their domain is all real numbers. Look at that fancy. X is an element of script letter medieval King Arthur R, right? Instead of the double bar R. The range is everything from 0 and above, okay? It's your smiling graph. If you reflect that across the line y equals x, and you get rid of the bottom part, remember, you get the inverse of x squared, which is the square root of x. It also has a vertex at the origin. Its domain now is everything greater than or equal to 0, and the range is everything greater than or equal to 0. So we got rid of the bottom part of the parabola, okay? Then we had x cubed. We've seen x cubed. That's your parent function for all cubic functions. And the domain is all real numbers. The range is all real numbers. And the vertex, which is the inflection point, is at the origin. If you reflect that across the line y equals x, you get the graph of its inverse, cube root of x. Vertex is still at the origin. Domain is still all real numbers. Range is all still real numbers. This is the one that on the previous test a lot of people missed. On the back page, if you remember, it asks for the domain and range, and it started as a cubic function, and some people thought it was the square root function, and they restricted the domain to the right of the vertex and above the vertex, instead of just saying double bar R, double bar R, double bar R, double bar R. There were 4 blanks. And I accepted that for each of the 4. Double bar R, double bar R, double bar R. Your turn. That's pretty good. Pretty good. You're not quite ready to be a pirate, but it was pretty good. You finished? You put it on my desk? You're done. Wow, that's fast. Okay. So today we're going to look at solving equations that involve the square root of x and the cube root of x, okay? And the first method that we're going to look at is solving them graphically. Graphically. So here's example 1. I have the cube root of x minus 5, and I want to know where it equals x plus 1. So if we interpret that graphically, here's what we're going to do. We could say that this is y sub 1, and this is y sub 2. And I can graph them individually on a grid, an xy plane, and I can see where the 2 graphs do what? Intersect. That's what we're looking for. The intersection is the solution. It's the point they have in common. Okay? So it looks like they already graphed. What is this? Radical function 3x plus 5. What the heck? Why is that there? What is that? Who put that there? This is, or is that a separate equation? What? I have no idea what that is. Okay. I was going to use the grid, but it looks like someone's already using it, huh? I don't even know what radical function equals 3x plus 5 is supposed to be. Maybe it's a separate function. Let's just use the space below it. Let's make our own grid. What do you say? Now, here's what I don't recommend. I don't recommend solving something graphically by making your own grid, even though that's what we're going to do. You know why? Because when we put our marks, 1, 2, 3, 4, 5, they're not always spaced correctly. And when you're solving something graphically, you need it to be as exact as possible. So you either need the calculator or you need something that's pre-gridded, okay? Pre-gridded. But we'll try it. We'll see what we can do. This will give us an opportunity to remember how to graph it. How do I graph the cube root of x minus 5? Where did the vertex go? We shifted it right 5 and up what? No, I'm just looking at the left side. Yeah, up 0, right? So if I come over here, 1, 2, 3, 4, 5, 0. There's 5, 0. There's the eye of the huracán, right? The eye of the hurricane. That's all we did to it. So it's going to come in like this, and it's going to go vertically, and then it's going to come out vertically and do that. It's your origin symmetric function that just got scooted right 5. Yes, yes? Not so bad. Okay. Now I'm going to use red here, and I'm going to graph x plus 1. That's just a line with the slope of 1, isn't it? So I'm going to come up here to the y-intercept of 1, and then I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. There's my next point, and then I'll connect that with a straight line. Now notice I got to extend my cube root function out a little bit further. Here's where they intersect, right there. There's the solution, xy, or we'll call it a comma b. Now, do we have enough information here to find it? No, I have no idea what that's going to be. Here's what I do know about it. I do know that the x value of the solution is going to be negative, and the y value of the solution is also going to be negative. I know the solution is going to be in quadrant 3. I know that. But I don't know what it's going to be. So that's about all I can get from a sketch. The sketch is just something that gives you a ballpark figure. So guess what we're going to do if we're trying to solve it graphically? We're going to go to the graphing calculator. So if you don't want to get out of your seat, you don't have to. Remember, you can go to Canvas and go to the Minnesota link, Minnesota, graphing calculator, Minnesota link, and you can pull it up as a split screen here. Ba-da-ba-ba-ba, I'm loving it. Okay, so I'm going to go to y equals, and I'm going to put the cube root of x minus 5 into y1. Now, about 4 or 5 different people asked me through the course of 12.1 and 12.2, how do you type in the cube root on your calculator? And I said, Math 4. And they went, thank you. But we don't need to know the cube root to type in the cube root of x minus 5. If that were the 4th root, there is no 4th root button. There is no 5th root button. There is an nth root button, but we don't have to do that either. Because we can write that as a fractional exponent, can't we? Yes, let's write this as a fractional exponent. The cube root of x minus 5 is the same as x minus 5 to the what power? 1/3. Yeah, baby. That I could type in, okay? Parentheses, x minus 5, caret. We know where the caret button is, right above the division symbol, to the 1 divided by 3rd power. There it is. And then in y2, I'll put x plus 1. And then remember, if we're going to graph it, your calculators may be in a wacky window because we were using them last period. You should hit what to graph it every time to start with? Zoom what? Unless you have data in there, you should hit zoom 6. That's your standard -10 to 10 viewing window. Whoa, they go fast. All right, so as I predicted, the solution is in quadrant 3. But now I have to find it by hitting what? Second trace number 5. Is this your first curve, boss? Hit enter. Yep. Is this your second curve, boss? Yep. Hit enter. Yes, boss. Okay, I'm going to scroll over to where I think the intersection point is, and I'm going to hit enter. And it tells me it's at -3, -2. Now, for the solution, here's the thing. Do I want to list the solution as an ordered pair? Or is it just the x value? If you look at the original equation, we're saying some value of x on the left-hand side, when you plug it in, will give you the same output when you plug in that same value of x on the right-hand side. Are we looking for the y value or the x value here? We're looking for the x value, right? It's nice to know what the value on both sides is going to be. I know that -2 is going to equal -2, but we're looking for the x value that makes it so. So the solution is not an ordered pair. The solution is just x equals the x value. And you're done. Now you can verify if you want to. Let's verify. By hand, in our head. When you plug a -3 in the left side, what's -3 minus 5? -8. What's the cube root of -8? -2. And what do you get when you plug a -3 on the right-hand side? -3 plus 1 is -2. Yeah. So solving it graphically, it almost takes the fun out of it, doesn't it? Just type it in the calculator, punch a few buttons, and then it gives you the answer. It's like, I didn't have to work for that. I didn't have to work for that. That's not even worth a social media post, right? It's like, that was easy. Okay, let's come over here, and I'm going to try to interpret what this thing is intending for us to do. I believe this is intending for us to write an equation for the radical function. I believe that's what it's asking us to do. So let's do that. We will write the equation for the radical function. First of all, what is the parent function for this graph going to be? Is it a cube root or a square root? It's got to be a square root, right? Because it doesn't continue on like a hurricane. So it's got to be the square root function. Now, the square root function normally launches out of the vertex at the origin and goes to the right. How do I get it to reflect over to the left? A negative where? In front of the whole thing or in front of the x? The whole thing is an x-axis reflection. If it's just in front of the x, it's a y-axis reflection. So I got to have it in front of the x. And then I also got to move it what to get the vertex from y equals 0 up to y equals 1? Up 1. Yeah, up 1. So let's see if we can get the equation. I think it's going to be the square root of negative x plus 1. I want to know where that equals 3x plus 5. All right, if we want to try sketching this by hand, the first one's already sketched. I'm going to go to the y-intercept of 5. Here's the other equation, 3x plus 5. And then I'm going to go down 3, 1, 2, 3, and left 1. Down 3 and left 1. And notice this one is going to be a little bit easier because the graph is already gridded for me. See that? Can I see now where these guys intersect on the grid? Yes, they intersect right there at what x value? Negative 1. In fact, they intersect at negative 1 too. So what's the solution here? X equals what? Negative 1. Yeah. Now, here's the other risk of doing it graphically. Even when you have a grid, they don't have to necessarily intersect at a nice integer. They could intersect somewhere in the middle of a square, and then you're like, I only know it intersects somewhere between 0 and negative 1, or somewhere between negative 1 and 2. You can't get down to the exact decimals unless you use the calculator or unless you solve it by hand. So as good as graphing it is, it's not the premier method that I'm going to teach you in this section. The premier method is how to do it algebraically, how to toil with it and get your hands in there and move the soil around until something comes out of it. That's the fun way to do it. This is kind of the boring way to do it. In fact, we don't even need the stinking calculator anymore. Solving radical equations algebraically. Now, there is a sequence, okay? The first and foremost step is to isolate the radical or the fractional exponent. Isolate it. That means get it by itself on one side of the equation. That's what isolate it means. That doesn't mean like banish it to the island of Elba. That's a Napoleon joke. No? Okay. You isolate it by getting it by itself on one side of the equation, either the radical or the rational exponent. Remember, rational exponent is the radical in disguise. Where'd I go? It's still me, guys. It's still me. Where's Korpi? He's here, right? Once you do that, you raise both sides to the power of the index or the reciprocal power. So if you have a square root, you square both sides. If you have a cube root, you cube both sides, so on and so forth. If you have the fourth root, you raise both sides to the fourth power. Or the reciprocal. If you have it to the 1/2 power, you raise it to the second power. If you have it to the 1/3 power, you raise it to the third power, so on and so forth. If you have it to the 2/3 power, you raise it to the 3/2 power, so on and so forth. If it's a fractional exponent, you raise it to the reciprocal power. Then you simplify and solve, and then number 4 is probably the most important thing. Whenever you raise both sides by a power, you run the risk of letting imposters into your solution set. What do we call imposters that don't work? We call them extraneous. So you got to check your answers. You got to check them by plugging them back into the original problem. If they work, hey, welcome to the club, buddy. If they don't work, you kick them out and banish them to the island of Elba. You got it? All right. Me. I'm warming up my voice for example 2. It's ready to go. Solve algebraically. Solve algebraically. All right. First things first. I got to identify the piece that has the radical or the piece that has the fractional exponent. I just highlighted it. I got to get that by itself. I got to isolate it on either side. There's a 2 in front of it, and the 2 is being multiplied. So to get rid of it, I have to unmultiply it. How do I unmultiply something? Divide it. So I'm going to divide both sides by 2, and I don't even show that. I just do it. So I get x plus 5 to the 1/3 equals, what's negative 8 divided by 2? Negative 4. Okay. There's step 1. I isolated the radical. Now, the next step is to, because it's a fractional exponent, put parentheses around both sides, and raise it to the reciprocal power. What's the reciprocal of a third? 3. Now, here's why it works when you raise both sides to the reciprocal power. When you raise a power to a power, you do what with those two? You multiply. What's the third times 3? 1. A third times 3 or 3 times a third is 1. That's why it works. You get an exponent of 1, which gets rid of the radical. So now you're just left with stupid highlighter. You're left with x plus 5 equals, and now we have to evaluate this. What's negative 4 times negative 4 times negative 4? First of all, is it positive or negative? It's going to be negative because there's an odd number of them. 4 times 4 is 16. 16 times 4 is 64. That's going to become a common one, so you'll learn that just by doing your homework, paying attention. 4 cubed is 64. Okay, now we're back in Algebra 1, aren't we? I got to undo adding 5, so I subtract 5 from both sides. What's negative 64 minus 5? Negative 69. Does it work? How do you know it works? That's how you know it works. It could be that there's no solution. There doesn't have to be a solution. It could be no solution. Whenever you raise both sides to a power, like a 3, like we did, the only guy that shows up could be an impasta. Let's try him out. Let's plug a negative 69 back in right here for x. What's negative 69 plus 5? Negative 64. What is negative 64 to the 1/3 power? That's the same as the cube root of negative 64, which is what? Negative 4. Whew. What's negative 4 times 2? Negative 8. Does it work? It works. So he's not an impasta. An impasta. Hey, I got out of a joke. What do you call fake macaroni? Impasta. Yeah, impasta. All right, the next one. Step 1, isolate the radical or isolate the fractional exponent. I have a radical term right here. I got to get it by itself. It's currently being subtracted with x. How do I unsubtract x? I add x to both sides. So I get the square root of x plus 6. You don't really need parentheses under there. The radical takes care of that. And you get x plus 4. Positive x, positive 4. Did I isolate the radical? I did. The next step is to get rid of it. Raise both sides to the what power here? How do you unsquare root something? You 2 it, right, because it's really to the 1/2 power. It's really to the 1/2 power, so the reciprocal of a half is 2. Yeah. So we square both sides. Now on the left side, you get x plus 6 to the first power, and on the right side, you get x plus 4 squared. Guess what we're going to have to do with x plus 4 squared? We're going to have to distribute. We're going to have to expand it out. We're going to have to like either off to the side on a workbench, write x plus 4 times x plus 4, and FOIL it out and combine the middle terms. Or, if you remember, I taught y'all how to square a binomial quickly so you don't have to go off to the side and FOIL. You remember this? Square, multiply, double, square? You remember that? Square, multiply, double, square? Square, multiply, double, square. Square, multiply, double, square. Square, multiply, double, square. Square, multiply, double, square. Here's how we do it. You square the first. What's x squared? X squared. The middle term is where you multiply and double. The middle term is multiply and double because when you FOIL it out, there's going to be 2 of them. So what do you get when you multiply them together? What's x times 4? Well, what's x times 4? 4x, and then you double 4x to get 8x, because when you FOIL it out, you're going to get a plus 4x plus 4x. So you multiply and double to get the middle term, so you get 8x. So we did square, multiply, double, and then to get the square, the last one, what's 4 squared? 16. That's how you do it. You don't just square the first and square the second. There's a middle term that people forget. That's the double product of the two. So square, multiply double, square. Or go off to the side and foil it on your workbench and bring it back in. All right. Now, we've done these types of problems this year already. Now I got to get everything on one side and set it equal to 0. So we get 0 equals x squared. 8 minus 1 is 7x. 16 minus 6 is 10. Okay. Now we're in good shape. I have a quadratic trinomial. I can either A, try to factor it, B, guess and check, or C, at the very least, I got the quadratic formula at my disposal, right? And if you forgot what it was, just reference your tattoo. There it is. What? Oh, it shouldn't be. I was goofing. This is me goofing. All right. 8x minus x is positive 7x. Are careless mistakes easy to make? Yeah, they are. Okay. I think this one factors, don't you think? We get 0 equals, and you can put the 0 on the right side if you want. X plus 5, x plus 2. Okay. So now that means x equals what? What are the two roots of the two factors? If x plus 5 is the factor, what's the root? Negative 5. And if x plus 2 is the factor, the root is negative 2. Do we box them both up, put a red ribbon on it, and ship it to Grandma and say, Grandma, here's the solutions? No. No, not yet, Riley. You could be sending Grandma a bad apple. Okay? We got to test them both out. Let's test them both out together one at a time. Let's try the negative 5 first. We'll plug it into the original line. Negative 5 plus 6? 1. Negative 5 plus 6 is 1. What's the square root of 1? 1. What's 1 minus 5? Negative 4. Ay, Chihuahua. Is that the same as positive 4? Is negative 4 the same as positive 4? Nope. Does it work? Nope. He's a fake macaroni. He's an imposter. He doesn't work. Does that mean the second one is guaranteed to work? Nope, it doesn't. We got to check it. It can be that there's no solution. So let's plug in a negative 2 up here for x. Negative 2 plus 6. 4. The square root of 4 is 2. 2 minus negative 2 is 2 plus 2, which is 4. Does that one work? Yes. Yes. Hallelujah. So that's all you have to do. If you draw an X through one of them and leave the other one visible, I know that you're excluding one and not including or including the other one. Okay? That's all you have to do. If it says to write it as a solution set, you could say X epsilon solution negative 2 close. That's writing it in a fancy way. That's like how you give it to Grandma. Here's my solution set, Grandma. What happened to negative 5? It didn't work, Grandma. I saved you from certain death. You got to watch them bad apples. They can kill you. All right. Let's come down here to the bottom left. It's a radical equation. Step 1 is to do what? Panic? Ah! Isolate. So isolate the radical. So I have a plus 5. How do I get rid of plus 5? Minus 5. So I get 2x plus 6. Red rover, let 5 come on over. What's 2 minus 5? Negative 3. Okay, so far so good. All right. Now I've isolated the square root. So the next step is to put parentheses around both sides and raise it to what power? The second. That's how you unsquare root something, is you square it, and you get 2x plus 6 equals 9. So 2x must equal 3, and x must equal 3 halves. Correct? Only one solution? It's got to work, right? We haven't, you get one solution. We got to have at least one solution, don't we? Not necessarily. Let's try it out. Plug in a 3 halves for x. It's a fraction, but watch what happens. What's 3 halves times 2? 3. The 2's divide out. So you get 3 plus 6, 9. The square root of 9 is 3. And, of course, 3 plus 5 is 2. What? 8? It's supposed to be 2. You got 8? Does 8 equal 2 today? Can 8 equal 2 today? No solution. Yeah, it doesn't work. No solution. No solution. So you can do this and then just say no solution. No solution. No soul. No soul. No soul. No soul. No solution. No. Either one of those will work. Anyone? Yeah, you can abbreviate like crazy. No solution. Holy smokes, Batman! We've got two terms that have fractional exponent. We're supposed to isolate them, right? Isolate them, which means get them by themselves on one side. Okay, if I divide the 2 right now, look what happens. It'll divide out here, but now I'm left with a 1/2 there. So I don't want a fraction, so I wouldn't do that yet. Well, I'll get it. This Korpi. I do have Valerie. She's anxious to leave. Yep, I'll send her down. Uh-huh. Yeah. I just made that part up, Valerie, that you're anxious to leave. I know you don't want to leave, but you are checking out. Okay, bye, Valerie. If I have 2 terms with radicals, how many sides of the equation do I have? Don't we have 2 sides of the equation, the left side and the right side? Hey, so do we have room for both of them? One on one side, one on the other. Would that isolate them? That should isolate them. Okay, so I'm going to leave this one here because it's positive. And then I'm going to move this whole guy to the other side. It becomes positive 2x minus 6 to the 1/4. Now, the right side is isolated. Yeah? The left side is not quite isolated. It's got the 2 in front. But this poses a problem now because the other side is already taken by another radical. So if I get rid of the 2 over here by dividing by 2, he's gone from this side, but now he shows up as a 1/2 on the other side. And to get rid of the 1/2 on that side, I multiply both sides by 2, which means now I have a 2 on this side. So in this particular problem, there is no way, there's not a third side to put the 2 on. The 2 has to remain stuck to one of the 2 sides. He has to. There's no other way to put him. Do you want to leave him as a 2 on the left side or put him as a 1/2 yucky, gross on the right side? Let's leave him as a 2 instead of a 1/2, okay? I'm going to leave him on that side. It's not the ideal thing to do, but it's the only thing we can do. Now, because they're both to the 1/4 power, I'm going to put parentheses around both of them and raise both to the what power? 4. Now, let's do the right side first. Since it was isolated, it just becomes 2x minus 6. Here's how the 2 comes into play, though. And we know this because we just quizzed over it. That's really 2 to the first, x plus 1 to the 1/4. I would have to distribute the 4 to both exponents. Yeah? So that becomes 2 to the 4th times x plus 1 to the first power, which is just x plus 1. In other words, I have to raise both factors to the 4th power. The 2 gets the 4. There's no way around it. But the radical or the fractional exponent does go away like we expected it to do for the x plus 1. Okay, what is 2 to the 4th, by the way? Oh, that's, it's 8 times 2, right? Yeah, good one. I like jokes. So it becomes 16. Now we've done these types of problems in Algebra 1. We just expand everything out, get it on one side, and solve for x. So if I distribute, I get 16x plus 16 equals 2x minus 6. There's no x squared term, so here's our plan. X's, you go on the left. Numbers, you go on the right. Okay? So I get 16x minus 2x, which is 14x. And then I bring the 16 over, it becomes negative 16 minus 6, which is negative 22. And at this point, you might be thinking, I'm doing this wrong. But no, you're not. No, you're not. Now I solve for x by dividing through by 14, and I get negative 22 fourteenths, which simplifies down to what? They have a common factor of 2. So negative 11 over 7. Oh, man. Oh, man. Does that work? Oh, we got to check. Oh, my gosh. Oh, I don't want to. I just want to roll the dice. It's either works or it doesn't work. It either works or it doesn't work. You don't think it works? Let's try it. Let's try it. Negative 11 sevenths plus 1. 1 is the same as 7 sevenths, isn't it? One pizza, slice it into 7 pieces and eat all 7 of them, you pig? Is one full pizza. What's negative 11 plus 7? No, negative 11. What's negative 11 plus 7? What kind of 4? Negative 4. Good. This becomes negative 4 sevenths. Can I take the fourth root of a negative number? Is there a number that I can multiply by itself 4 times and get a negative? No, because it's either positive times positive times positive times positive, or negative times negative, which is positive, times negative times negative. There's no way. You cannot take the even root of a negative number. Can't take the square root, fourth root, sixth root, eighth root, 10th root, whatever. You cannot have a negative number under an even radical. So does negative 11 sevenths win? No, he doesn't. Should be no solution. Okay. We tried. No, no, I'm writing it wrong. No solution. Yeah. Yes, this is called extraneous. Yeah, sorry. I need to probably clarify that because it's going to ask you on the homework to list the extraneous solution. That's its way of making sure you did the problem, not just saying, it doesn't look like it works, no solution. The value that shows up, the value that shows up that doesn't end up working is an extraneous solution. It doesn't work. Thank you for the clarification. Oh, so going back, no solution. Yeah, so up here, negative 5 is extraneous. Correct. Yeah, like on this one over here, we got negative 69 and it worked. There's no extraneous solutions. No extraneous. Yes. Yeah, we're going to stop right there. We'll explain the error tomorrow.